All right, in this video, we're going to learn how to, whoops, changed my video on accident. We're going to learn how to do here it is, the Poisson Regression. And honestly, I have no clue if I'm butchering that name or not. This is named after the French guy who came up with it. What's his name? Simeon Poisson. Basically, this is a technique for predicting counts. So imagine if I'm trying to predict votes for somebody. Votes are counts. They're discrete. There's no decimals allowed. What else is unique about a count? Well, there's no negative numbers. You can come here to Wikipedia and read up on Poisson distributions if you want. But basically, all I want you to know is that we're going to use this whenever we're predicting a dependent variable. It's numeric, discrete, and represents a count of something, and so there will never be negative values. In fact, the tool will actually break and not work if there are negative values in it. So this is a perfect context to use the Twitter data in that we've used in prior chapters. So what I want to predict here in the Twitter data is the number of retweets. So I have a person who's tweeted. Now, if you remember, I've told you before, I randomly generated these names. The names are fake, but everything else is accurate. So this tweet comes from a female. This is not a reshare, so it's an original tweet. It was retweeted one time. This person has a clout score, which is a representation of their importance on social media. Clout score 42, sentiment of 1, which means it was a mildly positive tone to tweet. She tweeted from Detroit, Michigan. Here's the actual tweet with the link that she included and everything in it. Anyway, that's the data we're looking at. We want to predict retweet count. So let's come back here. We better add a select columns because we don't want to use the actual tweet text in this. So let's eliminate that real quick. Let's get rid of or include, F name down to, do we want even state and city? Let's keep this simple right now and just go through country. Although we do have quite a few countries as well, that might be more than I want to do for this example. Obviously we don't want name either. So let's do gender through sentiment. And we'll just look at the tone of the tweet and their clout score and whether or not it's a reshare to try and, and gender, to try and predict the number of retweets. So let's go ahead and split the data. There we go. We got a lot of data, so I'm doing 80-20 split. Random seed. Grab ourselves a train model. Score. Evaluate. Train model, we want to predict retweet count. Okay. We need to give it an algorithm. Zoom out there. Here we go. Poisson. Again, don't laugh at me if I'm butchering the name and you know what it's supposed to be. Score model, yes, append. What's its problem here, though? Oh, duh. Got to connect it to the training and testing data set. That should do it. Let's go ahead and run that. I'll pause it. Okay, let's evaluate. Evaluation results. Visualize. All right, R squared of about 9.2-ish%. Let's see how different that is now when we compare it to our baseline. So 9.2% for the Poisson linear. Let's run this guy. All right, let's take a look. Visualize. All right, 8.6%. So a Poisson model used in the appropriate context definitely does better than our baseline model of a linear regression. Let's see here. If there's anything else I want to share, I'm going to go back and put this guy in one more time to save this model with. Oh, there are a lot of parameters here that you can mess with. I am not going to get into the details on this video nor in this class. However, you can learn what all these things mean. Come here for a complete description here on the Wikipedia page.